Okay, so we are live. Let's do some sound check and see if you can see me. Sound check. Sound check. It seems that I'm live at least. Let's see if we got some sound also. Let's all write in the chat in Slack if you can hear me and if it sounds all right. It looks like I'm sending sound at least from my end. But we have a couple of more minutes, so let's see. Awesome, thank you very much. So we will start in 2 minutes. And we will continue with the basics of testing. More definitions, I'm sorry for that, but we need to learn the language of testing. And then I think we are going to start practicing also during this lecture. And I might need help from you because you've been programming Java more than me the last years. So, but I will do my best, but hopefully you can send me the correct version of the code in Slack. And then I can copy paste your code and that will probably work. And if you've started on the first assignment, you're probably better at testing in Java than me. Right now, because I've not used Jupyter, I might know this and that about different testing frameworks. But let's see what happens. So I think a good idea would be to have a programming editor, running, and perhaps the same that you use in the assignment. Just you can create new files and stuff like that. Then you can code along a bit. Okay, so it's 10:15, and I will start with the lecture. And I think we could just let Hannah in, perhaps. And we start with a little bit of recap from last time. And I think this slide is the one that I want you to recap. And let's make that a little larger. And in this slide, we can see that you remember that testing could be considered two different things. It could be validation and verification. And validation is, are we building the right product? So are we, solving the customer's problems? And then we have verification. And verification is usually what most people are talking about when they talk about testing. So verification is to compare the specification or the requirements of the program with the actual program, right? So, and this slide shows the process of that. So we have a specification. The programmer uses that specification in order to program. It could be an informal specification in the head of the programmer. It could be, only communicated orally or things like that. But the idea is that a programmer has some idea. It could be the wrong idea for this problem, right? So you could misunderstand someone that you're communicating with. So you do some error when you're writing the code, or you didn't think of everything. That is usually the thing, right? You're occupied with a single thought, and then you'd make some error. That may lead to a static fault. So we had a definition of a fault, which was that is a static flaw in the code. Could be also, in the configuration of the application. But usually we're talking about code when we're talking about bugs or faults. The program that this code is included may produce, or it produces an actual output, right? So the program produces some output, and that output, if it runs the code with default, with specific inputs, not always, it may lead to an infection. And that infection may be propagated to the actual output. So the code is run, that changes the state of the program from a legal state to an error state. And the error state may then be propagated up to the surface of the program where we can hopefully observe it. So if we observe the output, we may actually do mistakes when we observe the output. You remember the color of orange is many colors of orange. We might be mistaken, right? We might miss a number. We are not perfect observers. And we may use computers because they are better at making exact comparisons, right? So we get an observed output. I look at the screen, I see the number 9 or something like that. And then we also use the specification in verification in order to determine the expected output or the desired behavior. And then that could be 9.1 or something like that. And then we need to decide, and the decision was made by the oracle. Is 9 the same as 9.1? And this is a creative decision. In some cases, 9 and 9.1 is similar enough that we can say that these are the same. In other things, that is totally not an okay, right? So we need someone who decides, is this an okay output? So we can get 2 different versions of orange, right? But these could be they could be similar enough that we say that these are okay. Doesn't matter for us if it's one value wrong, right? So but we need someone who decides that. So I think that is enough for recap. And yeah, I think one more thing I want to say before we go further, and it was that yeah, maybe it was later. Yeah, in this one. So we may manually test our program, and when we're manually testing something, we as human are different at different times. We are also different from each other. We have different language. We have, different capabilities. We understand language differently. We interpret things differently, which means that two testers doing the same manual test case may come up with 2 different solutions, or 2 different conclusions, I mean. And such test cases that flip from successful to failure depending on not a change in the static code, but a change in circumstances. We call those flaky tests. And those are not good, so we want to avoid flaky tests. So we can be very careful in how we communicate the test case. We can be very careful in how we control the program state in order to set it up so that things don't change because of minor misunderstandings in how things work. We could be very careful in how we input things and stuff like that in order to make it less flaky. But this could also be the oracle decision. Different people have different opinions about stuff, so or different interpretations. So we had seen this slide where I showed that manual test cases, even if I thought they were really carefully constructed resulted in really different outcomes. So most of my manual test cases were flaky. I think I had like 30 or something like that, and none of those every student agreed on. So there were at least one student for every manual test case that thought differently from the big group, right? And in some cases, I even said that this validation thing, it was the 10 people here that were correct and the 53 people that were wrong, so to speak. So we manually, so we want to go to automation in order to, remove the sources of flakiness that we as humans do. But in order to go to automation, we lose a lot of the creative process of our humans, like the good thing that we are good at. We sort of loses that. Okay, but we're going towards automation, and then we need to think about a number of different things. So we're going to continue this lecture with more definitions, but I hope that we can, also go towards code. And I just want to warn you that I haven't been programming Java. I wasn't planning to use Java during this lecture, so I have not prepared for that. So I have not been programming Java. I have not used the latest version of JUnit. So I think I will rely on you to do stuff for me and help me through the chat in Slack. So, okay, but more definitions first, right? So the first definition is the input domain. And this is math language. So let's make that a little bit bigger. So the input domain is the set of all possible input to a program P. And sometimes the input domain is also called the input space. Okay, what does that mean? And I think that we can move to an editor right away, and then we take a look at this function. I'm going to close that because it has a bug. So this is we could call it multiply, and it has one factor or one argument A and another argument B, and it should return A times B, right? So very simple method. So the input domain of this is all possible values of A times all possible values of B. So we have all combinations of these two. So for instance, we could have A equals 0, B equals 0. That is one value, right? And then we have B equals 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we have, A is 1, and B is 0, and 1, and 2, and 3, and 4, and all these numbers. So there are, a lot of numbers in Java. So I think this should be, between, so max integer, I'm just Googling, in Java is like, so many. An integer goes from minus, it's 2 billion something, right? And to plus 2 billion, right? So it's 4 billion values. And then since both of those are in that range, actually the return value is also within this range, because we're also gonna return an integer. So but the combination of A and B is all those combinations, which is a lot, right? So we can see that the input domain for, I'm moving stuff, for this add or mul with two integers is to the power of 32 times 2 to the power of 32, which is a huge number. Which means that if I want to test everything, that's so-called exhaustive testing, I need to run that many tests to be certain that the method works. So the input domain is all possible values for most non-trivial methods, and for most non-trivial inputs, this becomes too large to test everything. So when you have a couple of booleans, you can test everything, right? So if we have one boolean, we have 2 test cases in the input domain. If we have 2 booleans, we have 4 test cases. But this quickly goes to a number of test cases that is no longer possible. So the input domain is we cannot really do that. So that leads to a problem within testing, which is the test selection problem. So the test selection problem means that you want to select test cases that sort of gives you a good estimation if this is correct or not. So one way of mathematically talk about this is to talk about reliability. And the reliability is, we're going to use this definition here in this slide. The reliability of a program P is the probability of its successful execution on a randomly selected element from its input domain. So if I have 4 inputs and I randomly select one of these 4 inputs, let's say that we have two booleans, and I randomly select true and true, and it works for that, then we have 25% reliability at least, right? If I take another random number, I take true and false, and it does not give me the correct output, then suddenly I am at let's see, if I only take one, I actually estimate the reliability to be 100% because I have not seen any false. Now I have 2 different samples from this. I estimate the reliability to be 50%. And the more samples you take, the more different things you test, the higher reliability you get. But in order to do this, you need to randomly take samples here. If a function or a program works for every possible combination, then we call the program correct. So yes, so 100% reliability only means correctness if we also tested everything. If we tested everything. Exhaustive testing is when we test everything. And this is not possible in most cases. So what I want now is that let's take this multiply function and let's create a test case for that one. So I'm just going to save this one. And then I'm gonna, and I'm very, I'm not nervous, but I'm rusty in this. So I need to have one of these lecture classes, and let's call that system under test, and then new lecture, because I need the object. And I just call the class lecture. It's a stupid name, but And now I have an object, and then I will create a test case in JUnit 5. And I want to name that test case. And I'm going to name it specifically. And I just want to make sure that you pay attention now, because I want you to name your test cases this way. So the first part of it is the function under test within the system under test. So it's multiply, should, and then we say what it should do, what we expect, sort of, right? And in multiply, we expect should return 0 when input is 0. Normally, that didn't become a perfect thing here. Usually I do like this. Normally I want to have an abstraction of the numbers. Multiply should return 0 when something like 1 input is 0. And then we use the methodology or the words that we learned from the last lecture. So we have int input a equals 0, int input b equals 0. Normally, when when you're writing test cases, you don't want to be wordy. You don't want to talk a lot because you want to be fast, right? So during your assignments, I want you to be wordy and use these terms so that we learn these terms, right? And then I want to call the multiply method, and I call. Oh yeah, actually we want int expected be 0 also, because 0 times 0 should be 0, right? Actual equals system under test. We'll multiply on that, and then input A, and then input B. Yes. So far, so good. Now we want to compare the expected with the actual. And I mean, we could do something like this. And then we like system.out, print line. And that is sort of doing creating a report, right? But this is already a part of the unit testing framework. So one of the services that unit testing framework provides for us. So we should instead use the assert methods that has all of these capabilities included. So I get a question: do you recommend specifying positive and negative depending on what the intended behavior is? Yes. So I would say like multiply should pass when, I wouldn't say should pass, but I would say should, what it should do. I mean, it should return normally, or should work perhaps. So we normally, the pass or succeed or failure of a test case doesn't really need to be included, because it's a function of the testing framework. Okay, so now I want to compare these two, and I will use an assertion. And I actually don't know how to do that, but I think it's assert equals, and it does. And we can see that expected comes first. So I'm just going to write expected. And actual comes second. So actual. And that is all that I need to do. And then I can run the test case. And I'm sure you have also installed this plugin. And you can see that this test case fails. And we get the arithmetic exception, division by 0. Oh, we should not get a division by 0. So now we have found a bug. Okay. So if we look at the implementation of this, we can see that, oh, it's not a multiplication. And this would probably be everything we need to solve this super simple problem. And actually, for this method, I would probably just have one single test case. But for the sake of it, let's create another kind of bug, this one. And so I've changed this to another kind of bug. And just to show that, I mean, this passes from the test case that we have, which means that for some bugs, some inputs will not cause a failure, right? So we don't get infected from this. So for those cases, we might need another test case. So when both, so one should be both and one should one input. So I think that was, so let's have 5 or something like that. So now we have 2 test cases. They are different. So one has 0 in both inputs and one has 0 in only one. And if I run these test cases, see, it should find the bug. And probably for such a simple test, this, I mean, these two test cases are more or less overkill for this code, to test this code. But I mean, we could be like this, and we could still have problems with the code. For instance, what if this input from A is super big and the input of B is super big? What should happen? Should we return the highest integer? Should we throw an exception? Or what should happen? I mean, this is a number overflow problem, right? So we can't return the higher number. So I mean, what do you think should happen here if we get the number large enough? Yeah, throw exception could be one solution, right? So we could say this throws. And does anyone know the exception type for, a number overflow exception? Out of bounds? No, out of bounds means that you're out of an array, right? Yeah, throw with an exception, I agree on that. Number, let's see if you can find it. Sorry? Standard exception could be. Illegal argument exception, I think that in order to throw the illegal argument exception like I do here, well, then we need to say when an argument is illegal, I think. Yeah, so I get different kinds of solutions here. So Albert says that if we get the max, we could convert to long to see if it's an overflow or if max is actually the correct answer. Sure. Yeah, so, and Linda suggests how to test this, and I agree on both things. But I want to know if Java, I mean, this is actually a good learning experience for me also. So let's take this number. Let's create a test case, and let's call this something like multiply should throw exception when over or on when overflow. And then let's use this huge number as input A and this huge number as input B, and then we can actually just do it like this. We don't really know what would happen. Arithmetic exception, yeah, that could probably, but I'm just gonna run this and see what happens really. So, the build failed. Maybe we do it like that. And cancel. Can't I run? Oh, I don't want to fix anything. Now I actually don't know. Maybe we just say that it should throw that exception then. And let's copy paste from Linda. Should throw arithmetic exception dot class, I think. And then it's something like this, right? Then we copy paste this thing. And actually, I actually don't know how to do this. Is it the type? The name? Oh, let's find out. Yes. Insert throws, expected type. Oh, at thing, right? That looks better. Let's see if this happens. We run the test. Something did not work out. Insert. Okay, so I got an error here. Oh, I never specified the exception. Yeah. Let's see if that happens. Still something is wrong. So I'm not sure what is wrong. Sometimes, yeah, it could be that it's the thing. Do we need to specify that? How can I see the compile errors? Not really being programmed. Syntax. Oh. Yeah, okay. I'm getting so nervous, you know. That should be it. Now that looks correct. This looks more correct. Let's see if we can run the test again. Line 39. And we are still within that. This kind of syntax, I'm not used to that. It's not applicable for the arguments. So where is the, like this? You forgot to close the assert throws with a back bracket. Yeah, but isn't it that one? Oh, this one, right? Then I should have it. See, I mean, this kind of syntax I've not used, so this looks better, right? So we would expect an arithmetic exception to be thrown, but nothing. See what it says. Nothing was thrown. So what happens? I have no idea. Maybe we can find out by printing the thing that is outputted here. Close that. Something like that. Print line, right? Run it again. I would expect something to show up. Perhaps let's write suit multiply AB as the second argument for the assert throws. Now I think it must be an executable thing, right? For the assert throws. But at least we found out that the arithmetic exception was not thrown, right? Okay. So the interesting thing here is that when we go from one of we go from the code and we go to the test and we start asking questions about the code, and then we start finding more sort of requirements for the code. Nothing is thrown, so the error seems it seems that the error is silent. Perhaps this I have no idea. Maybe someone can just try to output the multiplication of these in a system out, and then we find out. Right? Okay, let's continue with this one. Even so, we are not able to test everything. There are simply too many test cases to run, and unless we have like forever to wait, we cannot prove correctness for most problems using testing. So if we are really need correctness, we need to do something else. And actually I mentioned that during the last lecture, and I called it here program verification. So if you have a problem that is super critical, that it must be correct, then you will do a mathematical proof instead that this code will work. It's not an easy topic, but we have given courses here at Linnaeus University in this. So there are ways to do this. But that is actually not testing. That is something else, right? Okay. So that was input domain reliability and correctness and exhaustive testing. So this is the sort of program, or the test selection program is the problem that we're facing. That, okay, we cannot test everything, so what should we test? We need to select test cases depending on how important the thing that we're doing is. So the left screenshot here is from Age of Conan. There is supposed to be a horse that this figure is riding on. This particular game did contain a lot of fun bugs, a lot of, the world is sort of exploding in different things, and that the horse is invisible and people are still riding around on it is just funny in a game, perhaps. But some bugs make games not playable, right? So I think this, was it called Cyberpunk or something like that? That was released a couple of years ago. That was, they screwed up. It was not playable for many people. So this hurts our confidence in the product and hurts the customer's confidence in the product also, right? So it could still be important to have a high, reliability for a product, both for the developers and for the end customers. But at least in games, no one is getting killed. Sometimes software is killing people, right? So we have had a number of tragic accidents, and this YouTube video is not from this is from launching I think it was a satellite or something like that, but this is billions of dollars at least in money. And there were a software bug in the guidance systems of this rocket that suddenly decided that you can do a 90-degree turn with a rocket going supersonic, which means that the rocket is going up now, and things seems to work, but suddenly it will try to turn in the air, even if it's going in too high speed. So it's going to break up soon here. So let's see that. Now the guidance systems yeah, now this decides I'm going to turn. And that was just a software error, a bug that costs us billions of dollars getting lost like this. Not a fun day at work for the people building that. But so in cases like that, then we need really careful testing processes in order to avoid that. And maybe you need to do programmer verification instead of testing. Okay, so we could decide on finding good test cases in the test selection problem, but this is a topic for a future lecture. And it's also sort of the topic of the first assignment also, right? Which test cases do I need? What combination of test cases do I need to find all different kinds of bugs, and what combination of test cases would be, needed in order to continue the development of this and be confident about it. Yeah. Okay, so we're going to continue with test levels and test types, but I think we need a break first. So let's see. So should we aim to do exhaustive testing for a first assignment? No, even in the first assignment, this is not possible with the kind of problem that you have. You can try it out, and we're going to show other kinds of testing here, like the random testing. So during this break, I think that since you have a programming editor running, do start with an exhaustive testing. So create a test case for perhaps the first assignment's add method, and see if you can test everything. You probably want to have like a system out print line inside the test case so that you can see output, because this is going to take a long time. But we're going to continue again, and let's continue 11 and 10, so 10 past 11. So, okay, cool. Okay, we'll soon start again. So I just want to, let's look at the cool thing that Albert did here. So he created a solution for multiply based on an assumption on how Java handles number overflows. Unfortunately, that assumption was wrong, right? But the cool thing here is that by testing, we are learning about how things work. So we can become, more knowledgeable of our system, and also, in this case, our programming language, by testing. And testing allows us to create a safe space. Oh, cool. Yeah, that is looks like something that could work, right? So perhaps we would need to handle this as another data type that can handle 64-bit numbers instead. I think Elijah's solution has a high probability of working. Okay. Hopefully by now you have created 2 for loops or something like that, and also started on exhaustive testing on the sum method, but perhaps you didn't come that far. I think just starting it and watching it run for a while, and then realize that this will take forever. Perhaps there is a timeout in JUnit. I have no idea how it handles test cases that takes really long to run. But this will just consume a lot of resources. So run it for an hour or so just to be convinced that there are too many test cases to be run. So that we need to figure out a way of handling the test selection problem, to create test cases that are interesting. So next up in this lecture is test levels and test types. So test levels are different ways of testing. So we will start with what we did now, which is unit testing. So normally we create a unit test, and then we create some code, and then we create another unit test, and then we create some code, and then we create another unit test, and then we create some code. Sometimes we have some code and we want to know if that code is working or not, and then we create unit tests for that code, like the scenario you have in for the first assignment. Within unit testing, we are testing one unit. What one unit is could be a method, it could be a class, it could be a component, or like that, right? But we are essentially, normally when we talk about unit testing, we're actually talking about like JUnit testing. So we're using some kind of framework, but it could be just I'm writing some code that is testing some other kind of code. Or I'm running just this method and I'm looking at the answers. It doesn't really need to be unit testing framework behind unit testing. You could do it manually. You could write if statements. You could write your own unit testing framework if you want to also. The next level is integration testing. And I really enjoy that you're still working on the integer thing and using math libraries and stuff like that. That is really awesome. Continue that kind of discussion. And we should, nerd down really here and find the different small, the breakdowns of the rules I'm trying to show you and stuff like that. And be careful and try different things. Be curious and dive deeper into the problems, even if many of the problems are trivial, right? Because we want to use these trivial problems so that we can learn from those, right? What are the limits of these trivial problems? Okay, integration testing is the next level. So integration testing means that we have 2 or more units that we want to know, do these units work together? So it could be, for instance, that you have 2 classes and you want to know, are these 2 classes collaborating in the correct way? So you use them together. It could also be an integration testing of 2 components within your system. So you could have like the back end and the front end and see if the front end is compatible with the back end. This requires perhaps more setup. There is more code running than when we have a unit test. The unit test had really good qualities that we want to, that I'm going to go back and remind you about this. So we had, for unit tests, we had accuracy, which is that we can isolate the faulty code. If a unit test, that one of the unit tests we ran for multiply or for the sum method, if that unit test fails, then we know that it's the error or the fault is in the multiply method, right? Because we have really good accuracy. We know that the fault is within this method. We can actually isolate it even within a method using some features of some unit testing frameworks, where you can see this exact code was run during a unit test. But accuracy is for unit testing is really, really good normally. When we test more components together, the accuracy falls because we are testing more code. So if there is a static flaw within this code, it might be found wherever in this code, right? We no longer know why a certain test case failed. Sometimes we do, but since we're testing more code and we get a failure, we need to investigate further in order to find out which line. And this was the problem when I had this blue screen bug, right? So I was running the entire system, the entire game, and I didn't know which line was wrong, right? And actually, the lines were not in my system. It was in the graphics driver. But the fault that I had in my system, that was I was missing the workaround. So it was a fault of omission. Okay, then the next level is system testing, and here we run all components involved in the system. So here you need to start up the database. You need to have that configured. You need to have the back end. You need to have the front end. All things. Perhaps you even have more front ends. You started everything. You're testing the entire system. So that is also sort of an integration testing where we test everything together. And when we are manually testing a system, we're usually doing system testing. And here the accuracy is even lower, right? We run everything. The problem could be in the front end, the problem could be in the back end, the problem could be in the database configuration, is it still unit testing if we start involving several system under test but keep the scope small? Okay, so I think the difference or the difference here between these different levels is a bit fluid. So for instance, we could do integration testing using a unit testing framework. So the difference here is mostly in your mind, right? So okay, I'm testing this component together with this component, trying to find out if they work together. Then you're doing an integration testing, right? You could still do a unit, a JUnit test with asserts and stuff like that to do this integration testing. But if you start up the entire program, if you run, the main method of the program, you start it up and you talk to the entire program, like I hope that you're also going to do during assignment 1, then you're actually doing system testing in that unit test because you run the entire program. So I think that if you have several SUTs, it sort of becomes the system under test is everything that you test. You can have several objects of your program, and they are together. If you test them together in an integration testing, they are together the SUT, right? They are together the system under test. Okay, and then we have a number of other test levels, which is sort of usually system testing or parts of the other ones, right? And we have a common name for testing is beta testing, and you've probably been involved as a beta tester for many products. There are beta testing is when we take a new version of our program, or the unreleased version of the program, and we test it on end users, but not in all end users, just some. So we say you are selected as a beta tester for our product, and you may try it out before everyone else, and everyone feels selected. Sometimes this is just a way of selling the product, and sometimes it's actually beta testing. So I have a friend that is working on in a big game company, and he said that, yeah, we're doing beta testing, but it's not really about testing, because the version that our gamers get early on, the beta version, is so far away from the version that we're working in. So we can't really use the test results from that. So in order to have a successful beta test, you must create a beta version, and then you collect information from your gamers or your customers, and then you use that information to change the product, right? To find faults, to find out how they use the product and stuff like that. But in their case, it was more like a sales thing, really. So they just wanted to get the word out, and people starting posting screenshots on Twitter, right? But usually when we're beta testing, we have a system, so we're testing the entire system. We could use end users to test an integration also, but I mean that is more where we're getting fuzzy then, right? Acceptance testing is also something that is used. Sometimes there is a contract between the ones that order the product and the developers of the product. And the contract may say that, okay, all of these requirements must be implemented for you to get money, really. So acceptance testing is a way of someone who ordered a product says that, yes, this is the product that I ordered. I accept this product. You can get your money now. This has been completed. It's usually, a validation. So you have like one test case or a couple of test cases per requirement. And you see that, okay, yeah, this has been implemented. This other thing has been implemented also. But acceptance testing can be, depending on how this works, right? How important this is. If it's life-threatening, if this gets wrong. Of course, the acceptance testing is also really, really and then finally, we have an important thing, which is regression testing. So if I have one code base and I run the tests on that code base, I come up with a test result. So some tests succeed, some fail. And then I change the code, and then I need to rerun my tests to know if the new version of the code succeeds the tests, fails the test, and that is called regression testing. So we regress, we do the same thing over and over again. Sometimes we have such large test suites. So a collection of tests are called a suite of tests. So sometimes we have such a large suites of tests that we don't want to run everything again. Then perhaps you do a test selection problem test selection within your suites, and you say that I'm only going to run the tests that are reasonable to be affected by the change I've made. So I know that for Google, for instance, for the Chromium project, so the Chromium project is an open source project behind Chrome browser. They have so many test cases, and they, programmatically calculate which test should we run when we run this again, because these test runners are running all the time, and they need, to save resources. And we want the test runs to be as fast as possible. And you have been programming for a while now. If it takes a very long time to test your product, then you're stopping testing the product. So if it takes 10 minutes to start up the program, and then you won't start the program because it takes too long to run. Right? So maybe you will, if it takes 10 minutes to run it, you will only test it once or twice a day, and not all the time, right? So we want regression testing. Actually, we want all testing to be fast. We don't want this to be a boring activity. We want it to be really, really fast. And yeah, so that was the different test levels. And then we go to testing type. And we have, and some of these you've probably heard, the black box testing is usually what you've heard about before. So black box testing, but there is also something called a white box or glass box testing, and smoke testing and random testing. So let's start with black box testing. And this is what you do in assignment 1. And actually, I want you to keep doing black box testing in assignment 1, even if there are techniques for doing looking inside the box, right? You could decompile the jar archive, right? And you could look inside and look at the code. But I think that it's a good idea to do black box testing first, at least. So black box testing means that, okay, we have a black box, a function that we're investigating. And we want to, from the outside, from the requirements side, or from the specification side, we want to explore this. And this is how I think you should work in assignment 1, at least first. You select inputs and you calculate yourself the expected outputs using the specification. But we don't know, we don't look at the code. That is black box testing, right? Black box testing is good because we don't get involved in code statements. And we are thinking about the requirements. And we're thinking like the customer. And we're closer to the validation, so to speak. But we're still in verification land. Then we have white or glass box testing. And when you see this code on the right-hand side, first you're reacting, ew, this is PHP. And then you're reacting, oh, there is a lot of if statements. And then some of you are reacting, oh, there shouldn't be if statements inside other if statements if you've taken another class of mine. But here we see that, oh, we have 1, 2, 3, 4 if statements and a try catch and a throw statement. So there's to test this method fully, we would need to have one test case that goes into each of the if statements and one test case per each of the message or the catch statements in order to cover everything, right? In order to go into each of these. We may also think about, oh, we need to combine things. Like, what if the first if statement, if we go into that, but then also goes into the second one, but does not go into the third or fourth one? That could be one test, so that we make sure that both of these things work together, right? And then we can combine everything here. What if the first thing is we should go into the first if statement and also username to short exception should be thrown. So we could do all the combinations. And here, when we have access to the code, when we have access to more information than we had in glassbox or in the black box testing, we could also, use that information to create test cases. So tests are no longer only generated from requirements, but from source code. Makes sense? And this is a really good way of working, actually, to make sure that, oh, I want to make sure that I go into each if statement. That is a good way of finding test cases. Yes. And then we have both smoke and random testing. So these techniques now is a bit different than most of the other techniques that we have been working with. So I get a question, is that what we call branch testing? Yes, so yeah, so if you go into different, if you're thinking that I want to go into this one and then I want to go into this one, then you're doing branch testing, yes. You're looking at the code as a tree and you're going into these if statement, yes. With a bit of uncertainty because I've not looked at the definition of branch testing this year. But maybe you can find a definition of branch testing and then post it in the Slack chat, and then we can see if this is actually true or not. Okay, so smoke testing or random testing is built on an assumption that we want the system to crash or throw an exception, or throw an error, or end up in a faulty state that is very visible. So but if we have a system that only has silent errors, like Java seems to do when we multiply two really big, when we should get an overflow, but we don't get that in Java. That is a silent error. So we could not detect that kind of problem with smoke or random testing. So this is built on the assumption that things will crash. So for instance, you've been working with compilers with Java, and you know that if you write your code wrong, you will get a compiler error for most texts. If we just pick a random text on internet and we put that into a compiler, we will probably get an error because that is not Java, right? But if we would do that enough times, we would also pick things that are legal input, but that should not cause a crash. So smoke and random testing are built on this. So we push in random stuff, and then we see, does it crash? And we may say then, for instance, that the system should not crash, or it should crash in a specific way. Okay, so we have different mechanisms for crashing. It could be the language errors or the errors included in the programming language. For some codes, for some states of program, the Java will crash. For other things, if we call a specific method, it will throw an exception, right? So we could say that, we don't want an exception to be thrown in our user interface. We should always get a good error message. So let's just input all the different things into the application's user interface, and let's see if it crashes for some input. We could have other mechanisms that I take from what's called defensive programming. And I encourage you to look into defensive programming, where you have in-code asserts. So you probably heard about asserts only in testing before, but you can also use asserts within your program for what is called invariants. So an invariant is something within that does not change. So there are some rules, for instance, for a class that does not change. So let's say that we create a class for a password. So maybe you have up until now used a string to handle handle a password, right? So you would store it in a string, and perhaps you have some if statements elsewhere in the code which says that, okay, this string must contain 3 different types of characters. It must contain at least 6 numbers or something like that. Maybe you have other rules also associated with the password. So let's assume that we collect all these rules inside the class called password. And all of these rules should always apply for every object of the password class. So we could say that, let's say that we create a function called invariant, and we place all the rules inside that. So we look at how many characters are in it. We looked at what character types it is. And when perhaps we have other methods that change the internal state of the password class, that changes the internal string. And then we could, after each change, like set password, right? That will be one of those. We could call this an invariant method. And it will throw an exception or cause an error if we actually set the password to something that is not correct anymore. That is called an invariant or in code asserts, and it's something that is included in defensive programming. So look into defensive programming. But the generic thing for smoke and random testing is that we input stuff. We hope that it crashes for the wrong things, right? Not everything crashes, but we hope for it crashes. So smoke testing, we want to look for smoke. So once I actually did see smoke from my computer, so I was young and stupid, and I was also very curious, and I said to myself, what happens if I change the sound driver to this other driver that I don't have? And what happened was that the speaker started screaming, and then I saw smoke coming out of the outlet of my computer, and then I didn't have a sound card anymore. So smoke testing, but that kind of smoke testing, this is not, right? But the idea is like this. We run as large part of the system as possible, and then we look for smoke. And smoke could be, for instance, that the system does not stop. So you run your program, but it doesn't stop. It should stop, right? If you run a compiler, for instance, it should stop. But if it's just continuing and continuing and calculating forever, then that is smoke. There is something wrong. It should stop after a while. It could be that you don't get any output. Maybe if you have a web application in PHP, that is a very common thing. Something happened, then you don't get an output. That could be smoke. It could be asserts that are thrown, like this in code asserts. It could be exceptions, error messages, log messages, outputs, like sometimes, you know, in the old days, the console application returned -1 when something was wrong. It could be all the different things that could go wrong. Random testing is, you know, a way of smoke testing. So we could, you know, smoke testing is to run as large a part of the system as possible. Random testing says that, okay, let's random what we input into the system. So if the string is inputted, let's create a random string and input that. And if you already did the exhaustive testing with a couple of for loops, it's probably pretty easy to create also a random tester for your piece of source code. So you create random inputs for A and B, and then you run it and see if it crashes. We could have random testing even for more elaborate kinds of inputs. So you can have, for instance, we can randomly generate code, and then we input that into a compiler. Yes, so that is no longer. So I think this was more or less the entire lecture for today, and hopefully we have come a bit closer. I think what I want you to do now is that I want you to really get into the first assignment, get started with it, you know, get it to run, look at the different test cases that exist already, thinking of what kind of test cases do I need to add to this in order to find out more about the system. And then think about this black box testing technique. Okay, what would be reasonable inputs to a multiply function? And what would be reasonable expected output from a multiply function? No, the multiply function is not included in your assignment, but yeah. And then I also want you to think about how should this really work? Like we were, you know, starting to think about this arithmetic exception. Perhaps the code that you got from Tobias and Tobias should also work in another way than it's actually, you know, written for, right? So think about the end user scenario of this. Oh, if I have a method for this and I send it, you know, a really large array or whatever, what should happen? Perhaps that is not included in the assignment description right now, but you could, you know, think about these things and then you reflect on these. And I want that you continue to ask questions like, okay, I can't run this at all. Really good that you asked that, like Pontus said, I think it was this morning, so that you get started and don't get stuck on stuff. Ask questions in the Slack channel. I'm very happy for all the activity in the Slack channel so far, and during this lecture. Really fun to see that. Do we have any preliminary deadlines, or it's still undecided? Yeah, so I need to look into the assignment and look what is reasonable for this one. So I think I could probably answer that question beginning next week. Yes. I think that preliminary deadline would be 1 to 2 more weeks of assignment 1. So really get started, right? Is there a requirement for how many bugs you need to find for each method? No, I want you to think about instead. Let's assume that there are a lot of different bugs. Let's think black box here. What could go wrong? Maybe a way of doing that would be to investigate the implementation by making your own implementation of this. So if you do your own implementation of, add or sum, what could go wrong? What is a reasonable amount of test cases for that? How many test cases do you need in order to be certain that there is no problem here? But I want you to I'm going to show this one. So this is the sort of correct implementation now, right? We are not throwing arithmetic exception, but let's simplify this like this. This is the correct implementation right now. Let's say we don't care about the overflow problem. But I mean, we could have this case. This is a bug, right? Really weird one. Oh, something like that. You would never find this bug by testing unless you do exhaustive testing. But this is not a reasonable bug either, right? So there could be bugs like this, right? That only happens for very specific inputs. So it's not reasonable that you do exhaustive testing. But you should do, if the code looks like, has a lot of if statement in it, if you would write the code for this implementation with a lot of if statement, you should think about, okay, what could go wrong when I write that sort of code? But think like a detective. Maybe for the multiply method, I would probably just have one test case myself. It's so simple. I just want to make sure that I have not copy pasted it wrong, right? So I would probably just have like 4 times could be 20. That would probably catch most bugs possible for such simple thing. Okay, thank you for listening. It's great to get started. I want to come to Växjö, but I'm not sure that it could be next week. But I think that I will probably write in Slack, and I will ask you how you want to meet me in Växjö, because maybe we can have like a tutoring session, and I get to meet all of you, and we talk about testing for you for a while. Is there any students from Växjö listening in right now? How would that sound like? And I think that we should have a tutoring session also online. If students from Växjö want to join the online tutoring session, that could also be a thing. But I think I want to go to Växjö and meet you, so that we get, you have a face on me, but I want a face on you also. And I'm really happy for the 2 students in the classroom today. Thank you very much for joining me here. It's super important for me to have. So where to find the latest slide? It's in the same, the last lecture, it's the same slides. I will post that, copy link, and I will post that into this one also. It's also available on the course homepage. So there are the slides. There you go, Josh. Thank you for the question. Yes. So see you next week. Follow things in Slack, especially if I pin things, because I will pin everything that changes. Cool. Thank you for your patience. See you next week.